Hello and a very warm welcome to Science Monitor, your weekly update on what's happening in the field of science, technology, research and innovation. I'm Frank Rausen-Pereira. Well, from the introduction of Asafoetida cultivation in the country to the successful development of a sustainable facility to process municipal solid waste, we have lots in store for you today. As always, let's begin with the headlines. 6th India International Science Festival to be held virtually. Council of Scientific and Industrial Research to spearhead the 2020 edition. Palampur-based Institute of Himalayan Bioresource Technology introduces Asafoetida cultivation in the country. Trial plantation undertaken in Lahaul Valley of Himachal Pradesh. Low-cost method developed to synthesize 2D tungsten disulfide nanosheets used in petrochemical industry. Technology developed by ARCI, Hyderabad. And municipal solid waste processing facility by CSIR-CMERI providing a sustainable solution to the problem of solid waste, also creating value-added end products. Well, keeping up with the new normal, it has been decided to organize the 6th edition of the India International Science Festival in virtual format. The decision was taken by the Union Minister, Dr. Harshvardhan, at a recently held review meeting in New Delhi. This year, the Council of Scientific and Industrial Research has been given the key responsibility to organize the festival, which will run from the 22nd to the 25th of December. It is expected that a large number of scientists, students and institutions from India and abroad will participate in the 2020 edition.
The India International Science Festival was launched in the year 2015 to encourage one and all, and especially the young minds, towards science by bringing science outside the classroom and labs. Since then, every year, this great fair of science and technology is being organized jointly by various departments related to science and technology and Vigyan Bharati or Vibha. In view of the pandemic, this year the festival will be held from 22nd to 25th December in a virtual format. This time, Council of Scientific and Industrial Research will spearhead the festival with support from all the other patrons and concerned departments.
Ministry of Science and Technology has been organizing ISF for last 5 years. First 2 times it was held in Delhi, then we did it in Chennai, then Lucknow, and last year in Calcutta. So this year, because of the very special situation of COVID, we have decided that we will not do a physical meeting, but rather an online meeting. So last year we had organized about 28 different events. This year we will actually increase it more. So our target is to do something like 40 events. And many of the new ideas that are coming up, they are not frozen yet. But we are thinking of, for example, sessions on history of science itself. Because many people are not aware of the development of science and technology in India.
IISF is a culmination of activities and events to celebrate the achievements of science and technology by involving all the stakeholders of science, ranging from students to technocrats. This festival has been organized in different cities of the country. Previous 2 editions were organized in Delhi, followed by Chennai and Lucknow, and the last one was organized in Kolkata. In 2019, 28 events covering various aspects of science and technology were organized, in which about 20,000 scientists, researchers and students took part. This time, the festival will be organized in a virtual format, and as more and more people are now comfortable with the virtual format, so many are expected to join from India and abroad.
We expect that total attendance will go in several lakhs. See, general public is very curious about what happens in our laboratories and all, and they hardly get to know what scientists behind the walls of laboratories actually do. And even if the general public tries to understand it, for many people is beyond their comprehension. But ISF is one such platform on which we tell people in their own language what happens and all, so that people feel excited and they feel involved, that why is society supporting so much of science and technology. So that's one of the major purposes of ISF.
Several events are expected to be lined up on various themes before and during IISF 2020. This year, besides promoting passion for science, IISF will also reflect on the role of Indian scientists and their capability to address global challenges like COVID-19. This program will also be a major platform to showcase science and technology innovations developed in India with the aim of global welfare.
Asafoetida or hing is used as a spice throughout the country. There probably isn't anyone who is not familiar with this ingredient, but an interesting fact is that it is not cultivated in India and imported entirely from countries like Iran and Afghanistan. Well, this may change soon as CSIR's Palampur-based Institute of Himalayan Bioresource Technology has recently started the cultivation of Asafoetida in Lahaul Valley of Himachal Pradesh. Here's more.
Asafoetida, found in our kitchen, is a major spice that has been used for centuries to enhance the taste of food and also as a medicine. But Asafoetida or hing is not produced in India. Every year, about 1,200 tons of raw Asafoetida is imported from Iran, Afghanistan and Uzbekistan, which costs around 100 million rupees. Now, with the exceptional efforts of CSIR's Institute of Himalayan Bioresource Technology situated in Palampur, the cultivation of Asafoetida has been introduced in the country. On October 15th, the institute started its cultivation by planting Asafoetida sapling in the Lahaul Valley of Himachal Pradesh in association with the Department of Agriculture of the state.
हमने ये पाया कि फेरुला एसोफोटिडा अफ़गानिस्तान, ईरान ऐसे देशों में पाया जाता है, तो हमने ये सोचा क्यों ना इसके बीज को अपने देश में आयात किया जाए। हमें सफलता मिली अक्टूबर 2018 में जब हम हींग ईरान से लाने में सफल हुए, और 15 अक्टूबर 2020 को मुझे ये जानकारी देते हुए बड़ी खुशी हो रही है कि हमने क्वारिंग से इसकी शुरुआत करी।
Worldwide, there are around 130 species of genus Ferula, and a few of them are also found in Himachal's Chamba, Kashmir Valley and Ladakh. But the species of Ferula Asafoetida, which is used for the cultivation of hing, was not present in India. In 2017, IHBT scientists approached ICAR, National Bureau of Plant Genetic Resources, and Asafoetida seeds were imported from Iran in 2018. After conducting initial research and development, the plants were grown in the Lahaul Valley on an experimental basis under the supervision of both the organizations. These plants thrive best in cold and dry desert regions, and as of now, Lahaul Valley is thought to be the best place for its cultivation in India.
ये पौधा शीत मरुस्थल जैसी जगह पसंद करता है, जैसे कि लाहौल स्पीति है, लद्दाख है, उत्तराखंड की ऊंचाइयां हैं। ऐसी जगहों पर ये हींग अच्छी तरीके से उगाया जा सकता है। हमारे वैज्ञानिकों की टीम ने हींग की पौध तैयार करी और वो सारे अध्ययन किए जो ज़रूरी थे हींग को किसानों के पास तक ले जाने के लिए। हमने एग्रीकल्चर डिपार्टमेंट और एग्रीकल्चर डिपार्टमेंट के जो ऑफिसर्स हैं उनके साथ मिलके इन गांवों में हमने हींग की पौध की रोपना करी।
Asafoetida is actually a gum resin derived from the tap roots of Ferula Asafoetida. It takes about 5 years to develop the oleogum in the rhizomes. Therefore, IHBT scientists and officials of the Agriculture Department have trained farmers of Lahaul village to cultivate the crop effectively. Now, the cultivation has also started in the demonstration plots prepared in Madgara, Biling and Keelong villages, and there is also a plan to expand its cultivation further.
हमारे संस्थान में हींग के ऊपर लगभग 12 साइंटिस्ट अलग अलग विषयों के ऊपर काम कर रहे हैं। इसमें सीड जर्मिनेशन से लेके इसकी एग्रोटेक्नोलॉजी, केमिकल कैरेक्टराइजेशन, इन सब के ऊपर कार्य हो रहा है।
जब हमने पहली बार सीड को उगाया तो उसमें हमें 1% के करीब जर्मिनेशन प्राप्त हुई, लेकिन फिर हमने लैब में इसकी सीड डोरमेंसी को तोड़ने के लिए कई एक्सपेरिमेंट्स किए और इसको स्टैंडर्डाइज किया। अब हमें 60 से 70% जर्मिनेशन प्राप्त हो चुकी है।
Successful cultivation of Asafoetida in the country will expand the bioresources of the Himalayan valley and also the income of the farmers. With the expansion of the Asafoetida cultivation, import expenditure will also reduce significantly. Moreover, the country will also become self-reliant in the production of Asafoetida.
Well, it's time now for a short break, but we'll be back with much more on the other side of Science Monitor. Stay tuned. Welcome back. You're watching Science Monitor. Well, Hyderabad-based International Advanced Research Center for Powder Metallurgy and New Materials, or ARCI, is engaged in developing advanced material-based technologies fulfilling the need of various industries. Now the scientists working here have developed an improved and commercially viable method of synthesizing two-dimensional tungsten disulfide nanosheets, which is of great significance to the petrochemical industry. Besides, this material is also a potential candidate for various other applications. Here are the details.
Industries play an important role in the economic growth and development of any country. And to carry out various processes, industries need efficient and low-cost materials in addition to scalable technologies that can play an integral role in enhancing their production. In India, Hyderabad-based International Advanced Research Center for Powder Metallurgy and New Materials, or ARCI, is one among the premier research and development organizations that are working in this sector. This autonomous center of the Department of Science and Technology is engaged in preparing indigenous advanced materials required by various industries. In this series, ARCI's Center for Nanomaterials has developed a superior and low-cost method of synthesizing 2D tungsten disulfide nanosheets. This material is used as a catalyst in petrochemical industries.
Most of the techniques for their synthesis that are developed all around the world are capable of producing only a minuscule amount and also non-reproducible quality of this product. In this regard, ARCI has made a major breakthrough with the successful development and demonstration of new scalable method on pilot scale that is capable of synthesizing these two-dimensional materials in bulk quantities with reproducibility and tunable qualities.
ARCI scientists developed the innovative method based on a controlled temperature and pressure approach. The method showed excellent capability in the bulk synthesis of 2D transitional metal sulfides. The team observed microstructure of the synthesized materials under a scanning electron microscope and found that the materials had a very high surface area. 2D tungsten disulfide has extremely low coefficient of friction, and this makes it a solid lubricant under high shear load in forging. This material is used in hydrogen evolution reaction and also as a petrochemical catalyst. 2D transitional metal sulfides are also potential candidates for applications in field emission tunneling transistors, Li-ion battery electrodes and lubricants.
These are used, as I said, in high technology applications in aerospace and automotive sector, in petrochem industries as a catalyst. Then sensors are also there in different type of gas sensors and other type of sensors, and as energy material, electronic materials. So it actually is a versatile material that can go to different sectors. So that is a unique thing about this type of materials.
Remarkable properties and potential applications of these graphene-like materials has triggered worldwide efforts to develop new synthesizing techniques. The unique and indigenous method developed by ARCI is not only cost-effective but also capable of producing reproducible quality materials in bulk quantities. The center has also developed a pilot-scale reactor indigenously, and the availability of indigenous material and technology will surely benefit the Indian industry.
Moving on, now solid waste coming out of factories, markets and residential colonies is a major problem in our country as it leads to various kinds of pollution. In order to provide an effective solution to this problem, a municipal solid waste processing facility was started by CSIR Central Mechanical Engineering Research Institute, Durgapur. And over time, it has incorporated various techniques to manage different kinds of waste. This sustainable facility has helped not only in achieving decentralized decimation of solid waste, but also in creating value-added end products. Let's see how this technology can help in realizing a zero landfill and zero waste city.
The rapid increase in population and urbanization has also led to an exponential rise in the daily waste that is being generated from homes, markets and factories. One can easily judge the enormous increase by looking at the landfill sites that are generally found outside our cities. According to the Central Pollution Control Board, more than 135,000 tons of garbage is generated daily in the country, and out of this, only 20% is treated effectively. The rest remains in landfilling sites and is called the dead waste. Untreated waste contaminates our air, soil and water and directly affects the health of the people. To tackle this problem, CSIR's Central Mechanical Engineering Research Institute, Durgapur, worked towards developing a sustainable facility to process municipal solid waste. Now the technology developed by the institute envisions a zero landfill, zero waste city by processing the waste in an environment-friendly way and by creating job opportunities.
पर अभी देखा जाए तो लॉजिस्टिक कॉस्ट भी एक कंसिडरेशन आता है कि जब आप गार्बेज को ट्रक में भर के या ट्रैक्टर में भर के लेके जाते हैं लैंडफिल एरिया में, जिसमें 15 से 20 किलोमीटर ट्रैक्टर चलाना पड़ता है, तो एक मैन पावर भी उसमें वेस्टेज होता है। डीजल जो हम इंपोर्ट करते हैं वो भी वेस्ट होता है, और साथ साथ में जो डीजल कार्बन डाइऑक्साइड देता है वो भी एक एनवायरनमेंट को पॉल्यूशन देता है। तो हम हॉलिस्टिक मैनर में देखें तो मेरे हिसाब से डिसेंट्रलाइज वेस्ट मैनेजमेंट फैसिलिटी हर जगह लगनी चाहिए। तो हम पेट्रोल या डीजल या इनका जो वेस्ट मैनेजमेंट का जो ट्रांसपोर्टेशन का खर्चा बचाएं, वो अगर हम उन लोगों को दें जो कचरा लेके जाते हैं, तो ओवरऑल हमारे हिसाब से ग्रोथ बहुत अच्छा होगा, जॉब अपॉर्चुनिटीज बढ़ेंगी।
The system developed by CMERI uses state-of-the-art segregation technology which is equipped to deal with a wide range of waste. For proper disposal, the institute converts solid waste into plasma using plasma arc technology, which obtains residues with better carbon content. These residues can be used as a fertilizer, or they can be used in the construction sector by converting them into bricks. The institute has also developed a biomethanation plant for making biogas from the organic waste. Targeting a zero landfill, the facility also has a pyrolysis unit which converts plastic into gas and liquid fuel. These fuels are used to run the plant, so the process is sustainable. Apart from this, technology has also been developed to achieve eco-friendly disposal of solid waste without forming toxic substances. In view of the corona infection, the facility has also added UVC light and hot air convection methods to kill all the pathogens, which is a very good idea to break the COVID-19 chain and to minimize other infections.
सेंट्रलाइजेशन मैकेनिज्म द सेग्रीगेशन फैसिलिटी और बहुत अच्छा है, इसमें यूवी ट्रीट होते हैं, चांसेस हैं कि पैथोजन ऑलमोस्ट किल हो जा रहे हो, और उसमें हॉट एयर एक्सपोजर भी होता है कचरे का, तो उसमें भी अच्छा सा रिजल्ट आता है। उसके अलावा प्लास्टिक का जो हमने बताया प्लाज्मा का, उसके अलावा हमारे पास पायरोलिसिस प्लांट है, जिसमें पायरोलिसिस में क्या करते हैं, उसमें टेम्परेचर 400 to 600 डिग्री पे करते हैं, ताकि वोलेटाइल मैटर जितना भी प्लास्टिक में हो उसको कंडेंस करके उससे ऑयल बनाया जाए, और उसी ऑयल को हम कहीं और नहीं डालते हैं, उसी को रीयूज करते हैं उसी फैसिलिटी के लिए, प्लाज्मा पायरोलिसिस फैसिलिटी के लिए हम यूज करते हैं। तो इससे बेनिफिट होता है, वहाँ का जो सिन गैस है वो वहीं का वहीं यूज हो जाता है।
Decentralized waste management technology developed by CSIR-CMERI will reduce waste transportation costs in cities, while biofuels obtained by waste disposal will reduce dependence on fossil fuels. Proper execution will reduce the need for landfill and create an environment without waste. This technology will also boost green energy in India.
Well, it's time for another short break on the program, but stay tuned. We'll be right back. Welcome back. You're watching Science Monitor. I'm Frank Razan Pereira. Well, it's now time to have a look at other developments that have made news in the field of science and technology in our special segment, Science Express.
NASA spacecraft OSIRIS-REx has successfully collected samples from an asteroid called Bennu. This asteroid is currently 321 million kilometers away from the Earth, and according to the scientists, this exceptional effort can help in tracing the origin of the solar system and the beginning of life on the Earth. The OSIRIS-REx spacecraft was launched in 2016 for collecting samples from the asteroid, and it made its first successful attempt on 20th October after orbiting the asteroid for nearly 2 years. If the amount of the sample is sufficient, then the spacecraft will be directed to depart Bennu, and it will come back to Earth by the year 2023. The asteroid, about 500 meters in diameter, is essentially made up of many rocky debris and is likely to come close to the Earth in the next 150 years, though the chances of it impacting the Earth are very low. The inexpensive COVID-19 diagnostic machine developed by Indian Institute of Technology, Kharagpur, has been successfully validated by the Indian Council of Medical Research. According to the IIT Kharagpur researchers, the portable COVID-RAP device can perform the test more easily than the laboratory-based tests, and the results will be as accurate as the RT-PCR test. Moreover, results can be obtained in an hour via a custom-made mobile application for dissemination without requiring manual interpretation. This kit will cost ₹500 per test, and the price can reduce further with mass production. The device was designed to make the test more affordable and easier to conduct. Scientists in the Netherlands have discovered a new organ in the human throat while carrying out their research on prostate cancer. Scientists have identified a set of salivary glands deep in the upper part of the throat and have named them tubercle salivary glands. Until now, the presence of only 3 large salivary glands was known in humans. One under the tongue, one under the jaw, and one at the back of the jaw and behind the cheek. The researchers confirmed the presence of the newly found glands after examining at least 100 patients. The scientists think that this discovery will help in conducting radiotherapy without side effects, as all efforts will be made to save these glands from radiation, which were not known until now. Researchers at the New Delhi-based National Institute of Plant Genome Research have developed a new method to control sheath blight disease in crops. Sheath blight disease is caused by a fungal pathogen called Rhizoctonia solani, which causes severe damage to rice and tomato crops. A recent study by NIPGR researchers has found that downgrading the expression of the fungal genes may be helpful in formulating effective strategies against the sheath blight disease. This is the first time that the fungal genes have been inactivated in Rhizoctonia solani by interfering with RNA using the gene silencing method. Currently, the research conducted on infected tomatoes has been published in the journal Molecular Plant Microbe Interactions.
So that's all we have in this edition of Science Monitor, but we'd like to hear from you. You can send your feedback and suggestions through email. Our email ID is news@vigyanprasar.gov.in. You can also write to us at our address Vigyan Prasar, 5th floor, Prithvi Bhavan, Lodi Road, New Delhi, 110003. That's it from me. See you again next time.